Hi everyone, this is Dr. Sheena here. Today we'll have a discussion on pin retained restoration. It's a very small topic, still relevant topic for your PG NEET entrance exam. So a pin is actually pin retained restoration is a restoration where we'll be actually applying pins like one or more pins onto the dentine which provide proper retention to the tooth structure. So you can see in this image there is a pin that is placed which actually support this restoration. Mainly there are three types of pin, that is the cemented pin, friction lock pin and self threaded pin. So what is a cemented pin? Cemented pin, as the name suggests, we will create a space or a pin channel that is larger than the pin which we place, and the pin and the channel is attached by a cement. So that is why it is called a cemented pin. As you can see in this image, the pin channel is actually larger, and into that we actually place the cemented pin inside this. So normally when we place the cemented pin, it is placed in such a way that 3 mm goes into the dentine and 2 mm is actually seen in the outer surface, right? So it was actually introduced by Mark Lee in the year of 1958. Mainly there are two types, like the size of 0.027. So since its channel size is larger, the diameter will be smaller. That is 0.025, 0.021, which is actually 0.020. Now, the cemented pins are actually cemented using either zinc polycarboxylate or zinc phosphate cement. Next is friction lock or friction grip pins. So talking about the friction lock or friction grip pins, it was actually found by Goldstein. So here, as the name suggests, the pin is actually attached by the friction lock. Here the pin channel is smaller and the pin size is larger. So the pin has to actually go into the pin channel. So it is tapped and placed within the pin channel and retained by the resiliency of the dentine. In the cemented case, that was actually retained because of the cement. As I said in the earlier, 3 mm went to the dentine. Here again 3 mm is seen within the dentine and 3 mm outside. There 2 mm was seen outside. Next is self-threaded pins. It was actually given by Going. The pin channel diameter is again smaller than the pin. So the pin channel diameter is smaller, the pin is actually larger. Different colors are available. You can see the number is like 2 mm is actually seen outside and 2 mm is seen inside. Now, which tooth have, this is the question that was asked, which pin have more of a retention? So just think, self-threading pin will have more of a retention, followed by the friction, and cemented will have least retention. Next is pulpal stress. We know that least will be in the cemented pins because the pins are smaller and it is attached by cement. So least pulpal stress will be on the cemented. More will be on the self-threaded, followed by the friction. And threaded made system is the commonly used self-threading pin. It is a type of system which comes under the self-threading pins. The relative position of pin from DEJ in pin rated amalgam must be 0.5 mm. So consider this as actually the tooth structure. Those dentine and enamel junction, it should be 0.5 to 1 mm away from the DEJ. Now there are certain rules that we need to follow when we do a pin retained restoration. First of all, think that this is the tooth and here one cusp is actually missing. They're saying that one pin should be placed per missing axial wall. Very important. The missing axial wall should be actually like compensated by one pin. The fewest pin possible should be used to achieve the desired retention, because more the pin, more the surface is involved, sometimes the retention might be actually affected. The pin should be non-parallel to one another. If it is like this, it should not be placed parallel. It should be non-parallel to one another. Pinhole should be parallel to the adjacent external surface of the tooth, but the material or the pin which we place should be parallel to the tooth surface, right? At least 1 mm of sound dentine should be seen once we actually place the pin. And the distance between two pinholes should be at least 1 mm, and the pinhole should at least extend 2 mm into the dentine. So these are the basic rules. First of all, one pin should be there in one axial, missing axial line angle. A fewer pin should be taken for the retention to take place. The pins, while placing, it should be in a non-parallel manner. The pin should have a parallelity between the external surface of the tooth, and 1 mm of dentine should be seen around the this thing. Distance between two pins should be actually 1 mm, and at least 2 mm of the pin has to go into the dentine. So that is actually the main important things that when we actually deal with the pin retained amalgam restoration. So what is the advantage of pin retained amalgam restoration? The tooth preparation is more conservative. Restoration can be completed in one visit. Retention form is improved by the use of pin. So all of the above is the answer. Threaded pin are used in large dental amalgam restoration to provide. So pins are actually a retention feature. It is not a resistance feature. It is a retention feature. Very important. Thank you. I hope you had a good class. Actually, it is a very small topic. Still, the important points have been covered here. Thank you. See you in the next class.